Bismillah ar-Rahman ar-Rahim. We are back. So now we are discussing this section 4.3, the first section after the second exam. So what we have in this section, or the section is talking about what? How to find when the function is increasing or decreasing. And also we have the first derivative test to find out when we have local maximum or local minimum. As usual, we will start by the basic about this section. So we define what's the meaning of increasing in general. It means if x1 is less than x2, then f of x1 will be less than f of x2. But however, we say it's decreasing. That means if I have 2 points, x1 and x2, x values, 2x values, and x1 is less than x2, then f of x1 will be greater than f of x2. And we call an increasing or decreasing function monotonic function. The test is very easy. Just we'll check f prime. We'll find f prime, and we'll check when it is positive, when it is negative. But we need to be careful. We take f prime as is. We don't do any change of sign or anything like that. Also, we need to be careful how to find the real line or the number line. When we do the number line to check the points, positive or negative, we need to put two things: critical numbers and the point of discontinuity. Okay. After we find increasing or decreasing, we can do the first derivative test, which is easily. Suppose that C is a critical number of a continuous function. If f prime changes from positive to negative, from increasing to decreasing, then I have local maximum here. However, if I have decreasing, then increasing, then I have local minimum here. If there is no change, it means f has no local maximum, no local minimum. Neither local maximum, nor local minimum. Okay, that's mainly the section. So now let us do some problems. I will start with easy ones. I need to check when it is decreasing, when it's increasing. So we need to find f prime. As I said, we need to find f prime. F prime will be what? 3x squared minus 3x, which is 3x times x minus 1. 3x squared minus 3x. Okay. So find the critical numbers. F prime equal to 0. That means 3x, x minus 1 equal to 0. So we have x equals 0 or x equal 1. So put this number line. I have 0 and I have 1. By the way, the domain of the function, Orion. Okay. Now I'll check. I want to check what? The sign of f prime. The sign of f prime. And this is f prime. Note f prime is 3x times x minus. So I need to check the sign of this. What I will do, I'll take a point here. Take, for example, x equal minus 1. Minus 1, it will be negative. 3 times minus 1 times minus 2, so it will be positive. That's what I care about. It's positive. That means the function is increasing here. Take a value here. I take x, for example, half. Who cares? So that will be positive. That will be negative. So that will be negative. That means it's what? Decreasing. Take a value here. X equal 2, for example. 2, positive, positive. So that is positive. So it means it's what? Increasing. So the function is increasing from minus infinity to 0. And from 1 to infinity. And it's decreasing where from 0 to 1. Okay, we'll do the same. Find where the function is increasing or where it is decreasing. We'll do the same thing. We'll find f prime, find critical numbers and point of discontinuity. Here we have no points of discontinuity. The domain of f is already a number. So we'll find f prime. That will be 12 x cubed minus 12 x squared minus 24x. 12x cubed minus 12x squared minus 24x. I will take 12x common factor. So that gives me what? X squared minus x minus 2. And that gives me what? 12x for x minus 2 times x plus 1. Critical numbers. I will make f prime equal 0. So I have x equal 0 and x equal 2. Or x equal minus 1. Okay. We'll put the number line as usual. Minus 1. 0. Here 2. Okay. So always try to remember f prime. F prime is 12x, x minus 2, x plus 1. Take a value, minus 2, negative, 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 so that is negative. Take a value between minus 1 and 0. Minus half will be negative, negative. This is positive, so it will be positive. Take a value between 0 and 2. 1 will be positive, negative, so that will be negative. Take a value here, x equals 3, that will be positive. So I have decreasing, increasing, decreasing, increasing. So it's increasing minus 1 to 0 and from 2 to infinity. And decreasing minus infinity to minus 1 and from 0 to 2. Okay. We'll do more problems, which is easy things. Same thing, the domain of f is all real numbers, just to be sure that we get it. You know, it's easy ones. F prime will be 3x squared minus 3. So that will be 3x squared minus 1, 3x minus 1 times x plus 1. Okay. Critical numbers. F prime equals 0. That means x equal minus 1 or x equal 1. So I have minus 1. I have 1. F prime. To take a value, minus 2. That will be positive. 0. That will be negative. 2. That will be increasing. That will be increasing. T plus 1 and 1 to infinity. Increasing minus 1 to 1. And the function, find where the function is increasing. Now we don't have the domain is not is not all real numbers, huh? So we need to be careful here. The domain of F is all real numbers except 0. So there is a point of discontinuity. Point of discontinuity at x equals 0. Okay, let us do. We'll do the same. In general, we'll find the critical numbers. So F prime will be what? Derivative of the first, derivative of the numerator, which is 1 times x squared minus 2x, x plus 1 over x to the power 4. That give me what? X squared minus 2x squared minus 2x over x to the power 4. And that, I will take what? I will take, yeah, it's minus x squared minus 2x. In other words, you can take minus x common factor. The remaining is x plus 2. Over x to the power 4. That will be minus x plus 2 over x cubed. Okay, be careful. I will take f prime as is. So my f prime is minus x plus 2 over x cubed. I will not say multiply by minus. No, you are changing it. So I'll find critical numbers. F prime equals 0. That implies x equal minus 2. X equals 0 is not a critical number because it's not in the domain. So now I'll put the number line. I have minus 2, and I have 0 open because it's not included. Okay, now we'll take a value for this function. Note I have the minus sign. So minus 3, it will be negative, 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 so that will be negative. Take a value to minus 2 and 0, minus 1, that will be positive. Negative times positive over negative, so that will be positive. 1 will be positive, positive, that will be negative. So it's decreasing from minus infinity to minus 2 and 0 to infinity. And increasing minus 2 to 0. Okay. Okay. Now we're taking more difficult functions or more interesting functions. This is my domain, which is between 0 to 2 pi. Okay. So I'll find f prime. That will be 2 cosine x times minus sine x minus 2 sine x. And I can take minus 2 cosine x. I can take minus 2 cosine x common factor. The remaining is sine x plus 1. Okay. Yes, be careful. This is my f prime with the minus sign. So I'll find critical numbers. F prime equals 0. So I have minus 2 cosine x sine x plus 1 equal to 0. That implies I have cosine x equals 0 or sine x equal minus 1. So I have x equal pi over 2, 3 pi over 2. From this, and when sine x equal minus 1, it's 3 pi over 2. So that's it. So we'll make this number 9. I have 0 pi over 2, 3 pi over 2. This is 2. Don't forget, this is my f prime. Minus 2 cosine x sine x plus 1. Take a value at each period. I have pi over 4, so that will be positive. That will be positive. This is negative, so that's negative. Take a value here, x equal pi. That will be minus 1. That will be positive. That will be sine by zeta, so that will be positive. Take a value here. We'll take 7 pi over 4, for example. I'll take x equal pi over 4. And x equal pi. And x equals 7 pi. But cosine is positive. So this is positive, negative, and this one is what? Yeah, it will be positive. Cosine x cannot exceed 1. So it will be minus square root 2 over 2 plus 1, which is positive. So that will be negative. Negative times positive times positive. So it's decreasing from 0 to pi over 2 and from 3 pi over 2 to 2 pi. And increasing from pi over 2 to 3 pi over 2. Find where the function is decreasing and find the local maximum, local minimum. Okay. You know what? Let me go back to all of these problems and check the local maximum, local minimum here. Okay. I will add local maximum, local minimum to these examples. Here I have 0. This is increasing, then decreasing, so I have 0 is a local, I have a local maximum here. I have a local maximum at x equals 0, and that will be 0. Just say I have f of 0 equals 0. F of 0. And here I have a local minimum, where I have f of 1 equal to what? 1 minus 3 over 2 minus half. I have a local minimum minus half at x equal 1. I have a local maximum 0 at x equals 0. The same thing here. I have local maximum, local minimum here, and I have a local maximum here. I have a local minimum here. Decreasing, increasing means I have a local minimum. Increasing, decreasing, I have a local maximum, and so on. This one, the same thing. I have local maximum here. I have a local minimum here. This one I need to be careful. Yeah, this is decreasing, then increasing, then this is decreasing. I have a local minimum here. I have a local. But here, no local maximum. It's not a local maximum. This is not a local maximum. Why? Because it's not defined. The function is not defined at 0. The function is not defined at 0. So it's not a local maximum. Here, I think increasing, decreasing, increasing, and this is decreasing. So I have local min here. They have local maximum here. Now let me continue. I have f prime is what? 6x squared plus 6x minus 72, which is I can take 6 common factor. That gives me x squared plus x minus 12. That gives me 6 x plus 4 times x minus 3. Minus 12, 4x minus 3x is x. Okay. So now critical numbers for the domain of f is what? All real numbers. Critical numbers f prime equal to 0. So I have x equal minus 4 or x equal 3. Number 9 minus 4. 3. Don't forget. What is my f prime? 6 x plus 4 times x minus 3. Take a value, negative, that will give me positive, that will give me negative, that will give me positive. So increasing from minus infinity to minus 4 and from 3 to infinity. Decreasing minus 4 to 3. Okay, that's increasing, decreasing, and this is increasing. And they have a local minimum, local max at x equal minus 4. Local min at x equals 3. Find the relative extrema. When they say relative extrema, they mean they want what? Relative max and relative min. So you see the word relative extrema means they want both. Relative maximum or relative minimum. Okay, we'll do the same. What's the domain? This is the domain. Okay. So we'll find f prime. So we'll find f prime. That will be what? Half minus cosine x. So this is my f prime. We'll find the critical numbers. F prime equals 0. That means half minus cosine x equals 0. So that means cosine x equal half. That means x equal what? When it's equal to half, it's 60. And in the first and fourth quadrant, so it will be pi over 3 and 5 pi over 3. These are the values. Okay. So I need cosine positive first and fourth quadrant. The same thing, we'll do the number 9. I have 0, 2 pi, and they have pi over 3, and they have 5 pi over 3. Okay, and this is f prime. This is my f prime. Okay, take a value here. I have, for example, pi over 4. So it will be half minus square root 2 over 2. Can't check it. F of pi over 4 will be half minus root 2 over 2. And that will be 1 minus root 2 over 2, which is negative. So that's the negative. Okay. Take a value here. Take pi, for example. This will take pi. So that will be positive. Very clear. Okay. What about this one? We'll take which point? Yeah, I know the angles. So this is what? We can do it by the angles. Or we can, yeah. This is 360. And this one is what? 300. So take any value between them. Take 330. As a degree. That will be what? Half minus root 3 over 2, which is negative. So that will be negative. So I have decreasing from 0 to pi over 3, and from pi over 3 to 2 pi, and I have increasing from pi over 3 to 5 pi over 3. Okay, that will be decreasing, increasing, decreasing. So I have local minimum at x equal pi over 3. They have a local maximum at x equal 5 pi over 3. Okay. Now we'll do more functions. We'll do more functions. I think the idea is very clear, but now we are doing just more functions. We are making the functions more complicated. That's it. But the idea is the same. Okay. Find the network schema of this function. Domain of f. Or real numbers. So we need to check critical numbers. F prime is what? 2 over 3 x squared minus 4 to the power minus 1 over 3 times 2x. In other words, it's what? 4x over 3 x squared minus 4 to the power 1 over 3. Okay. Need to be careful here. To find the critical numbers, I need to do two things here. F prime equal to 0, so that implies x equals 0, which belongs to the domain of f. So it's a critical number. F prime does not exist. That implies x squared minus 1 equal to 0. That implies x equal plus or minus 2. And both belongs to the domain of f. Since the domain of f is our ordinary numbers. Be careful. What is f prime? Huh? Always I need to put f prime in my mind. Okay. Now I'll put the number line. I have minus 2, 0, 2. Okay. So I take a value before minus 2. For take minus 3, that will be negative. Here I have minus 3 squared. 9 minus 1 is positive, so I have negative. To minus 2 and 0, take a value minus 1. That will be negative. That will be negative. And I have 1 minus 4, which is negative. So I have positive. Between 0 and 2, take a value like 1 will be positive over negative, so that will be negative. Take a value 3, positive or positive, that will be positive. So I have decreasing, increasing, decreasing, increasing. So it will be increasing from minus 2 to 0 and from 2 to infinity. And decreasing. It did not ask about it, but I think we can. It's good to do these things. And 0 to 2. Okay, he's asking about the relative extrema. So I have relative minimum at x equal minus 2 and at x equal 2. Someone he said is not defined in f prime. We don't care about that. It's defined in the original function. Domain of function is ordinary numbers. So I have relative minimum at x equal minus 2 and x equal 2. I have relative maximum at x equals 0. Okay, as I said, now we are just taking more complicated functions. Do the same thing. First, here I have x equals 0 is the point of discontinuity. Okay. Let's find f prime. By the way, is it the same one which we did before? No. Okay. So f prime will be what? Yeah. You can do it in two ways. You can deal with this function as x squared plus x minus 2. Or you can do it as a quotient rule. It's up to you. Okay, let me do it as a quotient rule. So I can do it quickly. I think from here it will be easy. Okay, let us do it from here to find the critical numbers. F prime will be what? 2x minus 2x minus 3. So take x minus 3 as a common factor, 2x minus 3 as a common factor. What's the remaining? I have okay. I have x to the power 4 minus 1. And that give me what? 2 x squared minus 1 times x squared plus 1 over x cubed. And that give me 2 x minus 1 x plus 1. Let me do it also as a quotient rule. In case someone want to do it this way. So I have what? 4x cubed. Just to show you it's the same. It should be the same exactly. 4x cubed. Okay. Times x squared. Okay. Minus 2x. X to the power 4 plus 1 over x to the power 4. And that will be what? I have 4x to the power 5 minus 2x to the power 5. That will be 2x to the power 5 minus 2x. I can take 2x. This is cancelled. This becomes 3. So we have the rest is the same. Just to show you it's the same idea. So the way you like it. Okay. Now critical numbers are what? X equal 1 or x equal minus 1. We'll find f prime equal to 0. That implies x equal 1 or x equal minus 1 or x squared plus 1 equals 0, which give me no real values. So we'll ignore it. So we'll put the number 9 only for minus 1 and 1. Is it? No. Be careful. We need to put the point of discontinuity also. So we'll put minus 1, 0, make it open. So not forget it. Minus 1. And this is my f prime. And f prime is 2 x minus 1, x plus 1, x squared plus 1 over x cubed. Okay. Check the sign. Take a value for minus 1, take minus 2. That will be 2, which is positive, times minus 3, times minus. This is always plus. It's always positive over negative. So it will be positive times positive in the numerator, okay, which is negative times negative, and negative in the denominator, so that will be negative. To minus 1 and 0, take minus half. That will be negative, positive over negative, so that will make it positive. To minus when 0 and 1, take half. That will be negative, positive, positive. That will be negative, positive over positive. That will be negative. More than 1, 2, like positive, positive, positive. That will make it positive. So I have local, yeah, I have decreasing, increasing, decreasing, increasing. خلاص. So I have local minimum at x equal minus 1 and at x equal 1. Local max, we don't have local max because at 0, the function is not defined. No local maximum at x equals 0. We don't have a local maximum at x equals 0, since it's not defined at 0. The original function, the function itself, is not defined at 0. No local max. Okay. As I said, now we'll just do more functions, especially finding the derivative. That will be the only difference. The domain or real numbers. Yeah. F prime will be 1. This is a product rule. The first, which is 1 times the second, plus 3x, x plus 2 square. Derivative of this, which is 1, so I will ignore it. That gives me x plus 2 square times what? Times x plus 2 plus 3x. That gives me x plus 2 square. I have what here? 4x plus 2, which is 2 x plus 2 square times 2x plus 1. Okay, critical numbers, f prime equal to 0. So that means x equal minus 2 or x equal minus half. Make number 9 minus half minus 2. Be careful. What is my f prime? 2x plus 2 square, 2x plus 1. That will make no change because it's always positive or non-negative. So I'll take values here. Minus 1. Take a value here. Minus 1. That will be positive times negative, so that will be negative. 2 minus half and minus 2. We take a value. What is this? Sorry. This is minus 2. This is minus half. Okay. So take a value. That will give me negative. Okay. Take, for example, minus 3. Minus 3 plus 2. Square it. So it will be positive. Huh? This is negative here. Here I have negative. Okay. Minus 2 minus 2 minus half. We'll take minus 1. That will be positive. That will be negative still. To minus half up to infinity, take 1 or 0. Who cares? That will be positive, positive. So that will be positive. So it's decreasing, decreasing, and then increasing. So the function is decreasing from minus infinity up to minus 2. And from minus 2 to minus 1. And increasing. No. Yeah, increasing from minus half to infinity. I have a local max at, no, we don't have local max. No local max. No local max. Okay. I have local min at x equal minus half. What is that local min? He said he want to say the values. Okay. I need to find f of minus half. That give me what? Minus half times, correct? Yeah. Minus half plus 2 is 3 over 2. Good. That will be what? 27, the minus sign over 60. Correct? Yeah, 8 times 260. So that is minus 27. This is the exact value. This is the local min at x equal minus the value of the local minimum. Okay. Find the intervals and the local maximum values. Okay, same thing. What's the domain of f? All real numbers. So I have f prime will be what? Yeah, I think I can write x, f of x like this. It will be easier for me. So that will be 1 over 3 x squared minus 2 to the power minus 2 over 3 times 2x. And that will be what? 2x over 3 x squared minus 1 to the power 2 over 3. Okay. Second numbers, I'll check f prime equals 0. So that implies x equals 0. And I will check f prime does not exist. That implies x squared minus 1 equal to 0. So x equal plus or minus 1. Okay, so I'll put the same thing, the number 9, minus 1, 0, 1. And this is f prime. Don't forget, f prime is this. Take a value minus 2. Substitute, I have negative. This is always positive since I have even power here. So that will be negative. Minus 1 and 0. Take a value like minus half, still negative. Between 0 and 1, that will be positive, that will be positive. So it's decreasing. From minus infinity to minus 1, and from minus 1 to 0, increasing from 0 to 1, and 1 to infinity. So it's decreasing, decreasing, increasing, increasing. We have no local max, but we have local min. What is it? Local minimum at x equals 0, it's minus 1 at x equals 0. As I said, now just the functions are becoming complicated. Here the domain, I need 5 minus x to be greater than or equal to 0. That means x is less than or equal to 5. So that's my domain. Now let me do f prime. F prime will be what? 2x square root 5 minus x plus x squared times 2 square root 5 minus x times minus 1. Simplify it, that over 1. So that's give me what? 4x 5 minus x squared over 2 root 5 minus x. Okay. That will give me what? Minus 1x squared minus x squared, that is minus 5x squared plus 20x over 2 square root 5 minus x. So I can take minus 5x common factor, and I have what? X minus 4. Okay. Yeah, just I'm checking the calculations are correct. Yeah, it seems to be minus 4x squared minus x squared minus 5x squared. Okay. Or plus 20x, take minus 5x common factor, the remaining x minus 4. Okay. Now, f prime equals 0, I'm getting x equals 0 or x equals 4. Both are in the domain of f. So I'm okay with these two numbers. F prime does not exist. So I have x equals 5, which is also still in the domain of f. Okay. So we'll do the number 9. 5 is my border. And they have 0. And they have 4. Okay. Take a value. Minus 1. It will be positive. Between 0 and 4. Take a value. For example, 3. That will be positive still. Take a value between 4 and 5, 4.5. That is still positive. So the function is always increasing. It's an increasing function. So it's increasing. You can say from minus infinity to 5, or you can make it no local maximum. No local maximum. No local minimum. Okay. Or you can say increasing from minus infinity to 5. Okay. Find the term increasing and decreasing quadratic extension for this function. And also the same thing. And here second about quadratic asymptotes. Okay. Local extreme. Okay. What's the domain of f? For real numbers. So here I find f prime. Be careful calculation now. This will be 2 over 3. X is minus 1 over 3 times this. Okay. Plus x to the power 2 over 3 times 1 over 3, 6 minus x to the power minus 2 over 3 times minus. Okay, now the common factors. 1 over 3, x is minus 1 over 3, 6 minus x to the power minus 2 over 3. Okay, that's the remaining. 2, 6 minus x. Correct. Yeah, 2 over 3x minus 1 over 3, 6 minus x in the power plus or minus x. Correct? Yeah, this is minus. This is there. Yeah, minus x. That give me what? Here I have 12 minus 3x. 12 minus 3x over 3x to the power 1 over 3. 6 minus x to the power 2 over 3. That give me 3. 4 minus x. 3 cancel 3. Okay. Critical numbers. F prime equals 0. X equals 4. Belongs to the domain of F. Actually, the domain of F are real numbers. Huh? And F prime does not exist. That implies x equals 0 or x equals 6. Both belongs to the domain of F. Since the domain of F are all real numbers. And that will be 0, 4, and this is 6. Okay. And this is my F prime. 4 minus x over this. But this will make no change about the sign, since it's always non-negative. Okay, take a value -1, it will be positive, over negative, that gives me negative. Between 0 and 4, take 3, that will be positive, over positive, that will be positive. Between 4 and 6, take 5, that will be negative, over positive, that will be positive. More than 6, take 7, that will be negative. Wait a minute. This one is wrong. 5 will be negative over positive, that will be negative. Sorry for that. More than 7 will be negative, more positive, and that will be still negative. That's increasing. This is decreasing, increasing, decreasing, decreasing. So increasing, let me say decreasing, maybe better. From minus infinity to 0. And from 4 to 6. And 6 to infinity. Increasing. From 0 to 4. I have local max. At x equal 4. X equal 4, I have local max. A local min at x equal 0. Okay. Correct? Yeah. Is the last one before I stop this recording. Same thing. Also, we add vertical asymptotes here. Yeah, which is clear about 0. 0 will be. So let me do B first. Okay, so I need to check the limit. This goes to 0 from right and from left, because I know limit. This goes to 0 from right, 1 over x is plus infinity, but limit x goes to 0 from left, 1 over x is minus infinity. So that will make a difference. Now be careful. Yeah, I need L'Hopital's rule to do this. So I will not do it. Yeah, just ignore this one. I'll do it later, maybe. I need L'Hopital's rule because it will be 0 times Yeah, in one case it's 0 times infinity. Leave it for the time being. We'll do it later. Since we did not do limit resolve until now. In one case, as it goes to 0 from right, it will be 0 times infinity, which is undetermined, which we need limit resolve to do that. I'll do it later. Okay, now we'll do the first one. What's the domain of F? For real numbers except 0. Okay. So we'll do F prime. Product rule, that will be e to the power 1 over x plus x times e to the power 1 over x times minus 1 over x squared. Okay. That will give me what? I can take e to the power 1 over x common factor. I have 1 minus 1 over x. And that will be what? X minus 1 e to the power 1 over x over x. Okay. Critical numbers. F prime equals 0. So I have x equal 1. If prime does not exist, will be 0, which is not in the domain. خلاص. So I'll put these two numbers, 0 and 1. 0. Check the signs. Before 0, take a negative value. This is always positive, so no worries. This will be negative over negative. So that will be positive. Between 0 and 1, take half. That will be negative. Take 2, that will be positive. So it's increasing, decreasing, increasing. So increasing from minus infinity to 0 and from 1 to infinity. And decreasing from 0 to 1. I have local minimum at x equal 1. No local maximum. No local maximum. Why? Because it's not defined at 0. The function is not defined. So you have only local minimum at x equal 1. Okay. Yeah, now we'll go to these multiple choice questions. So I will stop here. Thank you.